Sawadika. Hello everyone, this is me, Teacher Christina again for our online class. Welcome back. Okay, so last week we studied about graph of linear equations. Now today we will learn another math lesson for today. Now it's called a simultaneous linear equations in two variables. Okay. So this is quite different with the previous lessons that we've learned. Now this one is a two different linear equations. So it is a system of two linear equations. Now we call it simultaneous linear equations. Now to check if the two equations are simultaneous linear equations, first, each equation is a linear equations in two variables, of course. Very important. Because our topic is linear equations in two variables. The second one is we have to make sure that the two variables of the two equations are the same. Okay, so first we have to check if the two equations are linear equations with two variables. Second, we have to make sure that the variables of these two equations are the same. Okay, and the third one, if there are pairs of value that satisfies the both equations. So to understand more of that, we have this one. Okay, first, so you can notice that in our examples we have two different equations. So that is why we called it simultaneous linear equations of two variables. So let's try to check if these examples are simultaneous linear equations in two variables with the three tips that I gave you earlier on how to check if the two equations are simultaneously linear equations with two variables. Okay, so first we have letter A. Let's check letter A. Now what is the first one? What is the first? If the two equations are linear equations. Okay, so let's check letter A. Is it a linear equation? 3a plus 3b is equal to 1. Yes. 2a minus b is equal to 9. Yes. Okay, so this is a linear equation. Check. Okay, let's check letter A. So what's the second condition? It said that the variables of the two linear equations are the same. So we have first equation, we have variable a and b. Second equation, we have variable a and b. Okay, so therefore this one is a simultaneous. Okay, so this is, I will just mark this one as S. Okay, so this is a simultaneous linear equations in two variables. Alright, how about this one, letter B? Letter B, let's check if this is a linear equations in two variables. So first equations, we can say that this one is not a linear equation. So therefore, number 2 is not a simultaneous linear equations with two variables. Alright, so next, letter C. Okay, letter C. Okay, so 5p plus q is equal to 8, p plus 9r is equal to 10. Both linear equations with two variables. Alright, second, let's check if the variables are the same. So we have p and q, p and r. Oh, so that is an r. So they are not the same with the first equation. So therefore, our letter C is not a simultaneous linear equations with two variables. Alright, so letter D. Okay, letter D here. Okay, letter D, we have 2x plus y is equal to 5, first equation. which is a linear equation, all right, in two variables. The second one, yes, still the same, 4x plus 2y minus 3 is a linear equations in two variables. All right, so check. Number 2, we have if the variables are the same. All right, so both variables are the same. We have x and y, and the other one also is x and y. And letter C, we have if they have a common value of the variables. So this equation here shows that they don't have a common value that satisfies the equation. Okay, so they don't have a common value that satisfies our equation. So therefore letter D is not a simultaneous linear equation. All right, now, teacher, how can we check that have the same value that satisfies the equation, right? So that's a very good question. No? How can we identify if they have the common value, if the two equations share the same value of the variables, right? That satisfies our two equations. Okay, so that is our next topic. All right, so our next topic is to find the pair of values that satisfies the two equations. No? So that we can say that the two equations is a simultaneous linear equations in two variables. So how are we going to do that? Now there are two different methods. Okay, two different methods. The first one is substitution method. The first is substitution method. The second one is by elimination. Okay, so again, the first is by substitution. Second, by elimination. Now, to check the pair of values of our two equations so that they will be simultaneous, so that we can say that the two equations are simultaneously linear equations with two variables. So first we will use the method by substitution. Okay, so stay tuned. All right, so the first step, okay, the first step you can see there, the first step, that how are we going to solve this one? Okay, so the first one we have take one of the equation and solve for the variable of x and y. So first we have, okay, so this is our equation 1 and this is our equation 2. Okay, so what are we going to do is to rearrange first. Okay, we have to rearrange one of the equation so that one of the variables is expressed in terms of the other. In this case, okay, so we have to rearrange one of the two equations. All right, so we will use equation 2. Okay, why equation 2? Because it's easier to rearrange, because the value of the y equation 2 is easier to change because of our y here have one coefficient, so it's no hassle to change. It's very easy. So when you see a given like this, so you have to change first the variable that have a coefficient of 1. Alright, so we will choose equation 2. Okay, so what is that? We have y is equal to negative 2x. Move on the other side, that will become 2x minus 1. Okay, so this is our equation 3. Okay, so that is the first thing. You have to rearrange, make sure that we have the variable here. You can change, you can use the x, you can choose the x, but like I said, it's easier if you don't have it's easier if the coefficient is 1, just like this one. So it's very easy to change, no hassle. Alright, so we have now the third equations. Alright, so let's proceed to the next step. Now, step 2. Okay, step 2, we have to substitute 2x minus 1 for y equation in equation 1. Okay, so we are going to change. We are going to solve equation 1 by substituting the value of y to 2x minus 1. Alright, that is the step 2. Okay, step 2, solve equation 1 by substituting the value of y to 2x minus 1. That's why it's called substitution method. Alright, so how are you going to substitute again? That is, change the value of y to the given value. Okay, so let's solve for that. Okay, so can I do it here? Okay, so already the board is very... Alright, so let's move here. Now we will solve this one, right? Okay, so we have 2x minus 3. Now we will have to change our y. Now what is the value of our y? 2x minus 1. So we have to 2x minus 1. Alright, what's next? Minus is equal to 7. Okay, so we have this one. Now where did we get this one again? 2x minus 1 from y. Okay, from this one. We change the value of our y in equation 1 to this one. Alright, so let's simplify. Alright, so we have 2x minus, alright, that is negative 3x times 2x, that is negative 6x, negative 3x times negative 1, that is plus 3 is equal to 7. Okay, continue, simplify that one. We have 2x minus 6x, that is negative 4x is equal to 7 minus 3. Negative 4x is equal to 7 minus 3 is 4. Now, take note, we have this one. Okay, so let's continue. We were going to, since what is the coefficient of x? That is negative 4. So we have to divide by negative 4. And we also going to divide on the other side negative 4. So we have x is equal to negative 1. Okay, so x is equal to negative 1. Alright, so we have the value of x. So I write it here. Okay, that is x is equal to negative 1. Okay, now again, we solve this equation. Solve this equation. Change the value of y to the equation 3. And solve that one. So we have x is equal to negative 3. Alright, so this is the value of our x. Now again, how many variables we have here? 2 variables. Alright, so let's solve for the variable y. So we have here x already, so we have to solve the variable y. Now looking at the 3 equations, 1, 2, 3. Now which here is easier to solve the y. Alright, of course, we will use the equation 3. Why? Because the y here is already isolated. Okay, it's separated already. So no more changing from equation 1 and equation 2. So it's very easy. You can use the equation 3 to find the value of our y. Okay, so let's continue. Okay, so I will change this one. Alright, so let's copy this equation. So we have y is equal to 2x minus 1. Alright, we have to simplify. We have 2. Value of our x. What is the value of our x? So this one. So that is negative 1 minus 1. Okay, so continue simplify. 2 times negative 1, that is negative 2 minus 1. So we have y is equal to negative 2 minus 1, that is negative 3. Alright, so we have the value of our y is equal to negative 3. Okay, so you can see now. Alright, okay, so again, where did we get negative 1? From this one, right? X is equal to negative 1. Now where did we get this one again? From solving equation 1. We changed the value of y to the equation 3. Alright, so I know you're still a bit confused. Okay, we will try to check if both equations have the same pair of value. Okay, so let's check for equation 1 first. Okay, so we have 2. What is the value of x? Negative 1 minus 3. Value of y? Negative 3 is equal to 7. Okay, simplify. 2 times negative 1, that is negative 2. Negative 3 times negative 3, that is positive 9 is equal to 7. So negative 2 plus 9, that is equal to 7 is equal to 7. So they are equal. Okay, so next, let's try this one. Equation 2. Okay, equation 2, we have negative 2. What is the x? Negative 1 plus, what is the y? Negative 3 is equal to negative 1. Alright, simplify. Negative 2 times negative 1, that is positive 2 plus negative 3 is equal to negative 1. So simplify this one, and like sign, subtract is equal to negative 1. Alright, so both equations are equal. Therefore, x and y have the same pair of value to satisfy the two equations. Okay, the two equations. Okay, so simple as that. Alright, so next example. Okay, so I have another example here. Okay, I have two equations. We have first equation, a plus b is equal to 2. Second equation, we have 5a minus 2b is equal to negative 4. That is our second equation. No, that this is not a times. This is our second equation. All right, now what is the first step again? We have to make we have to do another equations. All right, by rearranging either equation 1 or equation 2. Now this time I will use equation 1 because the two variables have coefficient of 1. Now you can choose either A or the variable of B. Okay, so this time I will use the A. Okay, A, that is equal to 2 minus B. Alright, so this is our third equation. Okay, so let's continue. Now let's move on to step 2. Substitute the value of this variable to either equation 1 or equation 2. Alright, so I will choose equation 2. Okay, so we have here 5. Now what is the value of A? Now we will change the value of A with this one. Say substitute the value of A with the given 2 minus B. Okay, so we have 2 minus B. Copy, minus 2 B is equal to negative 4. Alright, so let's simplify this one. We have 5 times 2, we have 10 minus 5b minus 2b is equal to negative 4. Okay, simplify. Negative 5b minus 2b is equal to negative 4. 10, move on the other side, that will become negative 10. Alright, simplify this one, that is negative 7b is equal to negative 4 minus 10, that is equal to negative 14. Alright, so following we have 2 negative 7. Why negative 7 again? That is the coefficient of B. So we have 2 divided by negative 7. So the same with the other side, negative 7. So we have B is equal to 2. Okay, so we have now value of B is equal to 2. Alright, okay, so we have first value. Okay, so you have B is equal to 2. Now let's try to find the value of the other variable. Right, so are you following? Okay, so again we just change the A with this one, 2 minus B. Where did we get this? From here. And then follow simplify. Alright, so if you have questions, just comment down below and I can get back to you. Alright, so step 3, we are going to solve the other variable. So since we have variable B now, we are going to look for the value of our variable A. Now, so like I said again, we have equation 3, which is the A is already isolated, so we can use this one and it's easier, no hassle in rearranging because we arranged it already. So we will use this one. So we have A is equal to 2 minus, what is our B? 2. So simple, 2 minus 2, that is 0. A is equal to 0. Okay, so that's it. A is equal to 0. Okay, so I have another example here. So we have 2x minus 3y is equal to 5. So this is our first equation. So this is our first equation. Second one is 2x plus 3y is equal to negative 6. This is our second equation. Alright, so now we have to make our third equations. Okay, so have you noticed, what have you noticed? All variables have exponent of all variables have coefficient more than 1. So we have here 2x, we have 2 and 3, the same also in the second equation. So how are we going to do that? to get the equation 3, we have to rearrange either equation 1 or equation 2. Okay, so this time I will arrange equation 1. Okay, so like I said, you can change either 1 or the 2 equation, either the first or the second equation. All right, so this time I will change the first equation, okay, with the value of our x. Okay, so very easy. X here, no, we've learned this one in our previous lesson. So since it has a coefficient of 2, okay, I will write it here. You have 2x minus 3y is equal to 5. All right, so we have coefficient of 2. So what are we going to do? That we of course move that one on the other side. It's equal to, now that is 3y plus 5. Alright, so since this have an exponent, a coefficient of 2, so we're just going to divide by 2 and divide by 2. So we have x is equal to 3y plus 5 over 2. So okay, this is our equation 3. Okay, so this is our equation 3. So we have value of x, 3y plus 5 over 2. Okay, so continue to the next step. Okay, I will not erase this one so that you can see earlier. Okay, so first is we're going to change this one. Okay, define the value of y. Like I said, you can use either equation 1 or equation 2. Okay, so this time I will use equation 2. Okay, let's substitute the value of the equation. Okay, value of the equation 2. Okay, so let's write that one here. 2x plus 3y is equal to negative 6. Okay, so this is equation 2, right? Now we are going to substitute the value of x from our equation 3. So we have 2. Okay, what is the value of x? That is, to this one, that is 3y plus 5 over 2. Okay, so plus 3y is equal to negative 6. Okay, so continue with that. We have, okay, so that one, of course, and then we have 3y plus 5 plus 3y is equal to negative 6. Okay. Alright, so let's continue. So we have here 3y plus 3y, that is 6y is equal to negative 6 minus 5. So 6y is equal to negative 11. Alright, now divided by 6, divide by 6, so we have y is equal to negative 11 over 6. Okay, negative 11 over 6. Okay, so let's write here the value of our y. So y is equal to negative 11 over 6. Is the value of our y. Okay, so let's solve for the value of our x. Okay. Okay, so we have here, no, we can use this one because it's already isolated. We can use equation 3. So we have x is equal to 3y plus 5 over 2. Okay, so let's simplify. Okay, so let's substitute the value of our y with this one. Okay, so that is 3. What is the value of our y? Negative 11 over x. So negative 11 over x plus 5 over 2. Okay, so let's continue. So we have simplify this one, that is 3 times negative 11, that is negative 33 over 6 plus 5 over 2. Okay, that is 2. Alright, so since this is fraction form and 5 also, of course, what are we going to do? LCM of that, we have 6 times 6 divided by 6, that is 1, times negative 33, that is negative 33, plus 6 divided by 1, that is 6, times 5, that is 30, over, copy, 2. Alright, so simplify, we have negative 33 plus 30, that is equal to negative 3 over 6 over 2. Okay, so this is over 2, so we're going to change that one, but negative 3 over 6 times 1 half. Okay, so let's continue. Sorry. Okay, so let's continue here. So we have, that is equal to negative 3 over 6 times 1 half, that is equal to negative 3 over 12. Or we can simplify this one by negative 1 over 4. So this is the value of our x. X is equal to negative 1 over 4. Okay, so x is equal to negative 1 over 4. Alright, so again, let's substitute. We are going to solve the value of the x by substituting the value of our y from here. So we have 3y, change the value of y, that is negative 11 over 6. So we have here plus 5 over 2. Now simplify that one. So we have this, continue, and you have x is equal to negative 1 over 4. Okay, so that is the first method. Now how are we going to find the pair of value of the simultaneous linear equations of linear equations in two variables? Now so this method is the first one, substitution method. So that is for today's lesson, system of linear equation by substitution method. Alright, so next topic we will learn by elimination method. So for the next video we will going to learn for that. So as of now, it says bye.